Okay, morena e tātou mai and welcome to this online hui. Kei te ata wete wete e mātou e tahi o ngā kaupapa mō te mahere whakamua o te kaunihira o te tairāwhiti mō ngā tau rua tekau mātahi ki ngā tau rua tekau toru tekau mātahi. No mai haere mai everyone, the Gisborne District Council would like to extend a warm welcome to you all watching this online hui. Where we are seeking your feedback and we discuss the topics in the 2021 to 2031 long-term plan, also referred to as the LTP. And the LTP sets out our work for the next 10 years. So this webinar begins with presentations, followed by a question and answer section at the end. And if you want to ask a question, please do so in the chat function live. Leave your email address in case we can't respond to you right now. And if you're watching the replay of this webinar, online hui, and you have a question, please send it to feedback@gdc.govt.nz. Today, we're talking about our water, and we have three of our subject matter experts joining us. Firstly, we hear from 4Waters Operations Manager, Chris Hopman, then Community Lifeline's 4Water Strategy Advisor, Wolfgang Katz, and ending our session today, we have Tracy Panton, our team leader of wastewater treatment. And that is enough for me, team. I now hand over to you.
Morena, I'm Chris Hopman. I've just shared my screen, and what you can see there is the very start of the Gisborne water supply. It's the back face of the H.B. Williams water dam. This council provides quite a number of services to the Gisborne area, including the supply of clean drinking water to Gisborne ratepayers. As part of your Lifeline's essential services, we provide water supply, wastewater treatment and collection, stormwater, as well as operating the land, rivers and coastal areas. The Lifelines group, or the water utilities section of the Lifelines group, does this with 4 full-time operators, and they are on a 24/7 basis on a duty standby roster. And as well as that, we're assisted by Fulton Hogan, who are our maintenance contractor. There's a map here, a schematic, where you can basically see the major components, the major nodes of council's water supply. In the bottom corner is A, that's where our dams are. And then just to above that, you can see what we call the Waingake treatment plant. There's also an additional treatment plant on the top left-hand side, which we take water off the Waipawa River, and then we feed that into Gisborne Township. Our main dams are Mangapoike Dams. The Williams Dam on the right hand side is our largest. The Clapcott Dam is the oldest, and Seang Dam feeds into the Clapcott. There's a total catchment area there of just under 500 hectares, mostly bush and mostly well protected. This is a picture of the Williams Dam. It's our largest dam. The maximum storage we have in that dam is 92 days. On the bottom left-hand side there, you can see what's our spillway. If the dam gets too full, it overflows into there and runs down a spillway structure. That dam is probably getting to be 100% full at the moment, in line for next year's, this current summer's water demand. The Clapcott Dam is our oldest dam. It was built in 1948. The head of the dam, you can see there, that structure there, that's actually aging quite a bit now. It's pretty close to 60 years old, and we'll be looking at refurbishing that in the short term. That has about half the storage of the Williams Dam, of about 45 days. The Sang Dam feeds into that dam, and has about 10% of the catchment. The majority of our water comes from the TRI bush catchment, which is a protected catchment which has a QE2 covenant on it. It's predominantly native bush, and that supplies about 70% of Gisborne's water. It does go dry in summer, and that's when we start using the dams and the other treatment area, which I'll move on to next. So the first treatment area from the dams and the bush intake is the Waingake treatment plant. It was built in the 1940s. It's extensively upgraded after Bowler in 1990. We had quite a few issues after Bowler, especially with the main line breaking into Gisborne. It supplies most of the water demand. It has different processes: clarification, filtration, coagulation, and there's also a chlorine input. About halfway into town on the Bushmere Road, there's another intake which is directly off the Waipoa River. You can see our intake pump station there on the top right hand side, and that's actually taking quite dirty water. It can take quite dirty water, and then on the left hand side in the photo you can see how it's relatively clear in our settlement ponds. Generally we pick and choose when we take water, but it's always a balancing act. Obviously the cleaner it is, the better we can treat it. There's another picture of the settlement ponds and the treatment building on the right hand side. Again, there's settlement, filtration, coagulation, filtration, and we're currently installing a softening plant because the water's, the Waipoa water is harder than the bush intake water. Then we start moving into town, and we have our distribution in town. The water comes in on the left hand side, and it's boosted by the Makaraka pump station. That basically raises the pressure in summer when there's a lot of demand on. That way we can maintain water into our main reservoir, which is the Hospital Hill Reservoir, which you can see on the top area there. And there's another reservoir on Knob Hill, substantially smaller, about a quarter of the size, still a substantial reservoir, and that's slightly lower so the water can flow into that reservoir. Because we're an essential service, we have to supply water 24/7, and we have to, and there's components of our network that could fail. So one of the big issues at the moment for us is the aging asbestos cement water lines that we have. We have a significant amount of those, and they're slowly deteriorating, crumbling. So we get quite a lot of water leaks from those. So we've got a progressive program of replacing them. We prefer to use polyethylene pipe or PVC just because it's more ductile. It means it can move around a bit more if there's an earthquake without failing. And as you can see, we've got quite a network of mains and rider mains, and quite a lot of valves, which are the dots in those pictures. So if anything does go wrong, we can isolate sections and still feed other sections of town. So in terms of resilience, we also have some interdependencies. If the roads are out, we have issues, especially that Waingake Road, but also Bushmere Road where the Waipoa plant is. And there are a number of bridges as well, and pipe bridges where we cross with our main pipelines, which are susceptible to flooding and scour. We have an extensive generator network, gen sets, just to make sure that we, even when the electricity goes out, we can still supply water. Everything we have is on an alarm system, a SCADA system, and we use that for monitoring when things go wrong. And we also have fuel dependency because we've only got limited diesel storage at treatment plants. And it was noticeable this year with COVID, big demand on diesel and petrol, and we had to work our way around that using our civil defence partners. And that just pretty much wraps it up for me for the water supply. You'll be able to ask some questions soon. And I'll hand you over to Wolfgang Kantz. Wolfgang's going to talk about where some of the water goes.
Kia ora koutou. I'm going to be talking to you today about the DrainWise program, and that is the council work program aimed at reducing how often we have the wastewater overflows into the rivers in the city. So why do wastewater overflows take place? So in heavy rainfall, we have that rainwater entering our wastewater system. As you know, rainwater is not supposed to get into the wastewater system, but in heavy rain events, that does take place. When that rainwater gets into the wastewater pipes, those pipes get too full and can no longer convey that water to the treatment plant. They can't get the water to the treatment plant. The pressure builds up in that network, which means that no more wastewater can get in. And as a result, what we have is we have wastewater overflows onto properties and out of manholes. So there's just too much rainwater getting to the network. The pipes can't handle it, and as a result, wastewater can overflow out of properties, of gully traps, or into roads out of manholes. Now, that presents a health risk to homeowners, and as a result, what we do is we open valves that allow the wastewater to rather flow into the city rivers, which still has an effect, but it's considered a lesser effect than the long-term effects of sewage flowing onto people's properties. Once we open the valves, that reduces the pressure in the system, and the wastewater stops coming out of manholes and out of gully traps. So how often does it happen? It happens generally between 1 and 4 times per year, so up to 4 times a year. And our target through this LTP process is to reduce that frequency of overflow from up to 4 times a year to once every 2 years. So it's a substantial reduction that we are aiming for. So how does the rainwater get in? So it gets in by 2 ways. One is inflow, and that's when the water flows directly into the wastewater system. So it doesn't pass through soil. It flows directly, for example, as runoff on the surface of the ground into a gully trap. That's a direct inflow. The other way is infiltration, and that's indirect, because that is when the rainwater seeps through the soil and over a much longer period of time percolates down into the ground and then enters the wastewater system through cracks in the underground pipes. Inflow happens really quickly, whereas infiltration takes much longer because it takes quite a while for the water to soak through the soil. This is an issue that is prevalent across New Zealand and internationally in all major centres and cities, and most cities have programs to reduce inflow and infiltration. It is impossible to completely prevent any rainwater from getting to the wastewater network, or put it this way, it's practically impossible, very, very difficult. And this is because we have asset renewal programs, which are based on age, and the oldest pipes get fixed first, which means that some pipes may be leaking but can't be fixed at any specific point in time. We have surveillance challenges. It's very difficult to monitor the entire network every year, so we can't always find all the problems in the network. We have, in terms of the wastewater system, approximately half is owned by the private homeowners, and the other half is owned or operated by council. And council there doesn't have any oversight on what happens on private properties and only maintains its own assets. It also doesn't, private property owners generally don't know what's underground, and don't generally have maintenance programs on the underground pipelines. Wastewater gully traps are set at certain heights, generally to the 1 in 10 year rainfall event. So if you have an event that's bigger than that, you could have water overtopping gully traps. Cross connections between wastewater and stormwater happen over time. And then all stormwater networks are designed to a certain level of service. And the standard in New Zealand and internationally is generally to cater for the 1 in 10 or the 1 in 5 year rainfall event. And so when you have rain that's bigger than that, you will have ponding, and you will increase the likelihood of rainwater getting into the wastewater system. So removal of all stormwater from the wastewater network is very difficult. Engineering codes of practice and guidelines do make some allowance for inflow and infiltration. And that's generally designed to allow for 4 times average dry weather flow. So when it rains, we allow for at least 4 times what you'd flow in the wastewater system as compared to what you'd expect in dry weather. So that does give some sort of buffer. The problem in Tauranga Gisborne is that the amount of inflow and infiltration is just very, very high, very high. And the public wastewater network does comply with accepted standards. So looking at this a bit closer, we've undertaken substantial modeling of the wastewater network to try to figure out how the rainwater is getting in, and we've backed that up with property inspections and other works. And what is very clear to us is that the highest contributor to rainwater getting to the wastewater system is from property flooding on private property, and roof water being directed into the wastewater system through gully traps or lateral wastewater pipes. This is all direct inflow. So on properties, we have ponding, and that water is able to flow over and into gully traps, or it gets into gully traps if they are cracked or otherwise broken. The second highest impact is from leaking private property wastewater pipes. So that's the pipes that go from the house to the property boundary. And then the lowest impact is from the public wastewater system, and there we will have inflow, infiltration. We can have infiltration through joints or other access points. And this becomes a bit clearer when we look at this diagram here. in the middle of the diagram, we have the property boundary line, and to the right of that is the private property. Now, all wastewater infrastructure to the right of that line is the responsibility of the private homeowner. All infrastructure to the left of that is the responsibility of council. So what you can see on the right-hand side is there are multiple points where the wastewater system is at the surface of the ground. And so we have inspection holes, or called property line clean-out holes, which are at ground level generally, or close to the ground. And we have gully traps, which are at ground level. And these are really areas where water can flow into the wastewater system. So that's direct inflow. If we look to the left of the property boundary line, the connections with the surface are very minimal. The public wastewater system only really connects to the surface via manholes in the center of roads, and those are generally areas where one does not have ponding of water, and therefore the likelihood of inflow in the public section is really low. At the same time, if we look at the depths of the underground pipes, on the private property, they are generally very shallow, between 0.5 meter and 1 meter deep, whereas on the public system, they are generally in the range of 2 meters deep. So the likelihood, or the time it takes for rainwater to seep into the ground, through the ground, and then into the wastewater pipelines is much less on the private property side than on the council section of the network. And lastly, we've determined that inflow is the primary way, is the biggest contributor in terms of rainwater into the network. And the council section of the network is generally impervious. That means very few areas where water can soak through. And whereas the private section, the large areas that are pervious, and therefore in those areas, that's where you would get infiltration. So based on that, we've determined that the majority of the problem is located on private property, but at the same time, council is investigating and maintaining and renewing its pipelines to make sure that its network is adequate. This is a slide showing some of the infrastructure issues or structural issues we have on private property. A number of pictures, such as the one on the top left and top right, show a spouting downpipe into a gully trap. Now, those are really significant issues because they direct rainwater straight into the wastewater system. So those are some of the biggest issues we come across. In other pictures, such as the bottom right and in the center, you can see some damaged gully traps. And then toward the top right, you see a gully trap which is not only has a downpipe into it, but it's also at ground level, so it's not high enough. In the bottom left, we have a picture of water flowing into a wastewater pipeline. So that would be the infiltration of rainwater through the ground and then flowing into the pipeline. And in the far left, bottom left, we can see an absence of adequate stormwater infrastructure on a property, where the rainwater from the roof is allowed to flow onto the ground, which then will cause infiltration. And if there's enough of that, it'll pond up and it'll cause inflow if it's able to get through or over the gully trap. So these are the sorts of issues we find, and we have a program of property inspections. And just as an indicator, out of all of the gully traps that we have inspected, more than half of them have had some error, some issue with them that has to be remedied. So the infrastructure on private property is really something that we need to address. What are we doing about it? So there are multiple different activities in the DrainWise program that we're rolling out to address these issues. One of those is an education awareness program, which hopefully you've all seen. with the billboards and in the videos on our website, but there are a number of other aspects also, and you can find that information on the website at www.gdc.government.nz/drainwise. And you'll get a lot more information on all the different things we are doing to reduce the inflow infiltration. And finally, our target, as I mentioned, is to reduce overflows from up to 4 times a year to an average of once every 2 years. And to achieve this, we will need to work closely with the public to make sure we are able to fix both the council managed and the privately managed aspects of the wastewater system. So thank you very much, and I will now hand over to Tracy, and then later on will be available for questions. Thank you very much.
Kia ora everyone. So I'm talking about the wastewater treatment plant today, and what we have in the long-term plan is the wastewater treatment plant stage 2 upgrade. So that is what we're talking about today. So we have, what you might be aware of is we've got an outfall that goes 1.8 kilometres out from the beach. The first section was a 1,500 foot section that went out, and then that was extended later on. So this was put in, it was quite a bit of engineering at the time to get this in place, and that's where our current wastewater is disposed of post-treatment. So we've been through a bit of a journey. So that pipeline was put in 1964. So the interesting thing is before then we were actually on septic tanks and on-site wastewater even within the city boundary. And another interesting fact is right up into the 1980s, we still had night soil collection here, which meant that while water was being pushed into the backyards of people, that the solid wastes were being taken away still. So that was quite a long change to get everything changed over to being put through milli screenings, which also happened in 1986. So over that period, more and more of the city was actually connected to a network which was actually combining to come to what was the milli screen plant at the Stanley Road site, which some of you might remember. And then 10 years ago, commissioned in December of 2010, we had the wastewater treatment plant stage 1 site, which is at Bank Street. So you can see that our biological trickling filter, which is the main aspect of our treatment at the moment, is nice in the middle there, and you can see that is obviously during construction. So going forward in the LTP, we've basically got the stage 2 design that we are currently working our way through, and was hoping to be commissioned by June of 2022. So how the wastewater is treated at the moment is that the wastewater comes in. We've got 2 different streams coming through. So we've got the major industry separated line, which basically comes treated from the industrial sites through a screening process and then gets combined with the treated domestic waste and goes out to the sea. And we've got the domestic waste which comes in. It is pumped up through some screenings process. Then it goes through into some grit removal. Then it goes across to our BTF pump station, or a biological trickling filter pump station, up and over the BTF where it gets recirculated, and then that goes out to the outfall pump station, which then gets pumped out to that outfall at 1.8 kilometres out to sea. So these are pictures taken of the current site and of the inside of the milli screening hall. So that's the one on the top left. And you can see the inside of that biological and trickling filter as it was during construction on the top right hand side. So it's quite a bit of an interest, and that was built over, I think, just over a year. So it was a very fast build at the time. So stage 2. We're expanding the stage 2 site. So where the current site is, it is going to be slightly closer to the ocean for the stage 2 site. So you can see that outlined in red on the picture on the screen at the moment. So the stage 2, you can see a little picture or diagram of what that's going to look like. And so the reason we're doing the upgrade is to make the discharged water a much better quality heading out to the marine environment. So that's going to have from our current biological trickling filter over into clarification, some tertiary filtration, and then UV disinfection or ultraviolet disinfection. And so that will then be the water that is being discharged. There'll also be sludge handling, an upgrade to the septoception, some odour control, and we're going to be using recycled water rather than using potable water. So that'll be a much reduced water intake for the treatment plant, and obviously mean that we're not using some of that potable water just to clean things that have been dirtied with wastewater. So whilst the colours will not stay the same, this is what it'll look like. So from the top right, that's sort of the clarifiers where that'll come through. Then you've got the 2 whitish boxes in the middle. I'm not sure if you can see my cursor, but these are the tertiary filters. Then it'll go through a UV, which goes along behind this building here, and that goes out to sea. So the solids from this clarifier and the tertiary filtration will end up going into these holding tanks, which will then pump through these sludge thickeners, basically. And they will end up providing a solid waste, which is primarily made up of the worms and snails and algae that is in the biological trickling filter treating our waste. And so those will go into containers or into a truck, and that will go for disposal. So this is the screens handling sludge hall, which is on the left-hand side of the screen, in case you can't see my cursor. So this process has already started. We've gone through quite a bit of the design process, and we've gone through early equipment procurement. So the orders for these have been submitted, and so these are either in the stages of being constructed, or they're in the process of being sent to Gisborne. So, and this shows just a slightly different look at the insides of what these look like. So you can see there we've got the clarifiers, which is a lamella type clarifier, tertiary disc filters, some UV disinfection, and then the sludge watering process. And obviously some extra pumps, because we need to be able to move it from one place to another. I think the combined cost of just the early procurement was around the $7 million mark. Oh, sorry. So one of the questions you might want to know is how clean will the water be at the end? So there's actually significant reduction going through the current biological trickling filter, but this will make it much, much better. So we're looking at having 3 log reduction, which is basically taking our enterococci levels under the 1,000 CFU per 100 mil. So that's colony forming units. And so that's quite a low amount for wastewater. And obviously these solids will be much, much lower as well. The solids did need to be taken out to be able to do UV disinfection as well. Otherwise, the UV disinfection wouldn't work. So the amount of solids now going out in the wastewater will be much reduced. So we are for construction. We've got registrations of interest, which are going out next month or the month after. We're looking at having a tender out for Christmas, construction starting in early of next year, and then operation by June of 2022. This is actually quite a tight timeline given the size and the scope of the project. It's at least the same size as the current site and will cost around about $30 to $35 million at its current costing. And that's just a pictorial version just showing what kind of water is going where on the site for interest more than anything else. So that is the stage 2 wastewater treatment plant upgrade. So that's it from me. I open it up for any questions.
Awesome. Thank you to our subject matter experts. And while we go live at 10 a.m, I imagine when we replay on Facebook at 6 to 7, that's when we're really going to get our questions. And just a reminder to those of you watching the replay, please send your questions to feedback@gdc.govt.nz, and that's how we can assure to get you a timely response. I do have a few questions from the email though, and this first one is for you, I imagine, Chris. One of the things we're asking about in the long-term plan in this early engagement phase is about drinking water, and whether or not our residents want us to apply more money to that, or do the same or do less. What is council doing to protect drinking water security in the long term? I'll just get you to unmute.
Done.
Council's aware that there's always a demand for water, and it's quite an extensive demand. A lot of people alongside our water supply lines would like water, but we can't provide it to them. And there's been quite a lot of development, both in industry and domestically in Gisborne. There's also demands or requests for water in some of the outlining areas, such as Wainui. So what we're looking at is we've looked at a number of sources, and there's currently one source that seems quite appropriate and quite large enough, and basically in the right catchment area behind Waingake, where a significant dam has formed through landslides, and a significant lake has formed behind it. A lot of cost, a lot of investigation to go forward in terms of making sure that dam's appropriate and to see what engineering is required to make it stable, but also quite a lot of cost and difficulty in getting a pipeline from those dams into our network.
It's an interesting prospect though, and internally we would have heard a bit about that. So if you have questions about that, send them through. I'm not sure how responsive we can be on that, but that's interesting. Another question, you mentioned it in you mentioned this particular stakeholder group in your answer, and I'm going to throw it to the team because it's a question we get asked often. Is council still considering reticulation at Wainui? And if so, when? And why? Why do you have that answer, I guess?
If I can answer that, we're currently relatively water short in Gisborne. We have restrictions every year. Wainui's a significant area to reticulate, and so it would be very expensive. But expense isn't really the issue. Well, it will be. But I think the major issue is the supply. And when we talked about that dam earlier, we also talked about, it's probably quite some time away. It would be in the 5 to 10 year plan. So in between, we are water short. The other issue that's aligned with water is that all water eventually goes into wastewater, or most of it does. And we do have limited capacity, a limited design for our wastewater treatment plant.
Thanks for that, Chris. Wolfgang, a question for you. So those of you who haven't had a chance to access the DrainWise education program or the resources that are available, Wolf mentioned that they are on our website, and they're very cool. They're very cool, so I implore you all to have a look. Wolf, you had a diagram in one of your slides. Can you just elaborate on what's happening in DrainWise? What does that mean, and what are the activities going on there?
Sure, no problem. So, yeah, when people think of drain-wise, they often think that it's limited to infrastructure and so on, but really there's a lot going on there. And we have multiple different bits that we're doing. The one bit we're doing is we have a program of inspecting all properties in a prioritized basis across the city to go and identify all of these issues and to help homeowners fix their private issues by providing guidance and so on. And when we find issues that are bigger than the responsibility of the private homeowner, we look at putting in public solutions to those into those areas. One of those is extending our stormwater network. So where we find significant ponding on properties, and that's caused not just by that property or the neighbors, it's caused by a bigger catchment issue. We are extending our stormwater network to help assist with that drainage. So that's quite a big program, and we are rolling out about 7 of those projects per year. We have I mentioned the education and awareness program, and we've had a real push with that in the last year and a half, and we're looking at going further there and also further engaging, particularly through schools and community groups to try and improve the understanding of the issues in the networks and so on. At the same time, we are looking to improve our notifications. We have a targeted program to upgrade our network to try and help with these issues. And over time, we will be engaging with homeowners in a more formal way to get that private property work completed. And when we do that, we are also considering the ability of the community to pay for their private infrastructure. And so we'll be applying an affordability lens to hopefully enable the homeowners to make those fixes. And that's probably the main aspects that we are working on.
And you talked a little bit about gully traps, and if a homeowner or a resident wanted to access one of our staff members to go and help them or needed more information, how could they do that? Is that quite simple?
Yep. So we really do want to work together with homeowners. If it's a minor fix like cracks, or it's too low and can quite easily be raised, we will do that for you. So if you get hold of us, we'll come out and assess your gully trap, and we'll provide you with the advice to fix it. If we can't fix it ourselves, if we can fix it ourselves, we'll fix it on the spot right there, or come back a couple of days later to do that. The best way to do it is probably to raise a query through the council RFS system. So just call the front desk, or there's also an email address that we can it's on the website, and we can provide it at a later stage. I can probably find it now. I don't know the email.
Thank you, Wolf. Also, just a bit of a plug for our GDC Fix-It app. You can download that on Android and iPhone, and it's a really simple and easy way to get that information to our front desk to then get you assisted. Hopefully quickly.
I can just let you know that that email address is drainwise@gdc.govt.nz. So that's drainwise@gdc.govt.nz, and that's probably the best way to contact us about these sorts of issues.
Awesome, thank you. Something else that just came through in the chat for you, Tracy, something that pricked up my ears also, solid waste being treated with worms and slugs and things like that. Can you elaborate a bit on what that means, what that process is?
So we have a biological treatment system in Gisborne. So there's lots of mechanical ways of taking waste or converting wastewater or cleaning up wastewater before it goes out So we have a very biological system. We have the biological trickling filter, which was that big round space dome thing that looked like in the middle of those pictures. And so what happens is the wastewater that we have, the incoming wastewater, is actually irrigated over the top. As it sort of trickles through this media, it goes through at a reasonably slow rate. So while it's in there, algae, different plants take up that nutrient, snails eat the algae, worms eat the algae. So we have quite a little ecosystem of bugs there that are actually effectively converting that what solids are left in the wastewater, because there is obviously screening prior, but converting it from a human waste effectively into a biological bug type waste. So what we're talking about when we're talking about the sludge waste coming off in the new upgrade, it's that biological load that comes off from the invertebrates and the snails and the algae. And it's quite interesting to see actually in the finished sludge, it does look quite gritty with a whole lot of earthworms just holding it together. So obviously it's quite a nice healthy environment for them. Hopefully that answers the question.
It's very interesting. It's very interesting. And I hope our people find that interesting too. And it's good to know, because that's not something that I knew internally. Now, one of the other things that we're asking about in the long-term plan in this early engagement is stormwater. So I imagine that's a question for you, Wolf, if you could just elaborate on the 162 kilometres of stormwater pipes we do have, or it might not be for you, Wolf, it might be for the team, just to give a bit more information and context to what it is that we're surveying at the moment.
I can start off, and Chris, if you'd like to jump in at any stage, by all means. So we have a very extensive stormwater network. That network consists of pipe systems and overland systems, and together they, in combination, give us that level of service that we need to service our community. We try and design the network to be to cater for the 1 in 10 year rain event. So that means that the flows from a rain event that has a chance of occurring every 10 years, flows up to that intensity can be handled within the network. Some of our network is designed to the 1 in 5 year at present, but over time we'll upgrade those to be the 1 in 10 year. And we'll also be looking at where we need to, considering the overland flow paths. So there's overland flow paths. When the network can't handle the flows go overland, and we're looking at making sure we protect those so that the flows are controlled and don't go underneath houses and so on. I hope that answers your question.
Do you have anything to add to that, Chris?
Yeah, it's interesting. We're judged on how many overflows we do have, and it's overflows that count are the ones that actually flood out people's houses, flood out their habitable floors. That doesn't include garages and low-lying buildings. Basically, the stormwater's in really good condition. We do a lot of maintenance on it. We have to make sure that all the grills are clear and clean on a regular basis, and all the sumps are as well. Stormwater also, things like the sumps actually provide some protection to the environment, because when we empty them out, they're full of heavy metals and things like that from the runoff from the roads. Things like brake shoe linings and those sorts of things. All the stormwater goes into the rivers at some stage, the lowest point. And yeah, those overland flows that Wolf was talking about, they also include roads. So sometimes, 1 in every 10 years, presumably, our roads might become a conduit for that stormwater. The nice thing about it is that sort of localised flooding disappears quite quickly. So that's and the reason we only design for a 1 in 5 or a 1 in 10 year event is obviously cost. If we went more than that, then we'd be spending more on stormwater. So it's a balance.
Interesting. It's good to have that kind of information when we're asking our people where they want their rates to be applied and if they want more to be applied in that area. A question that I've got here in the email for you, Tracy, is just very simply, if you had to state the main things, what's different about the new proposed wastewater treatment plant to the old one?
So maybe it wasn't very clear. So the current wastewater treatment plant is basically the wastewater comes in, we'll go through that whole plant, and then we'll go again through this next stage. So it will be in a series, not in parallel. So basically what we're having is we've got the level of treatment we have now, and we're actually improving that level of treatment to make sure that that stuff that goes out to the environment is much cleaner. But yes, significantly less solids, less bacteria. So things that we want to see made a lot better in the environment there.
And so that would go out on that 1.8 kilometre pipe that you mentioned that goes out into the oceans, and we would be expecting to be a little bit more environmentally caring when we discharge?
Yes, that's right.
Okay. Now I've got another question here. Team, I'm going to throw you this question and see what our answer is. It came through in the email, and it's based on water consenting and the fact that there's a huge waiting list. Is the process fair, and can you elaborate a bit more on water consents and how people get them or how people don't get them?
That's quite a difficult one. It's a regional council question as opposed to us. We're sort of more local government services supply. So I think it's I think it would be difficult to answer, and it's probably something for another day or for somebody else. What about you, Wolf?
Yeah, Chris, you're right. That is something that is best dealt with by regulator. We don't have mandate over that. I can say that they are looking at the process at the moment, and there's quite a lot on the go there, but really I don't know enough about it to be able to answer. It's not our function really, so we won't know about that.
It's an interesting process. Anyway, another question from the email. What happened to the wetlands that council was talking about a few years ago? It's an interesting question.
So with the wetlands, we did some trial work down at the wastewater treatment plant. So we actually put in a significant number of trials to see what the level of reduction of solids, bacteria, nutrients, all that sort of thing were going in. And what we found was that to be able to get down to a suitable level of treatment, similar to what we're going to be getting with this clarifier and UV, is that it was too expensive for Gisborne to actually afford. So while it's not out of the question, there is still work being done on that. There's work going towards that to look at what is the next stage after this next sort of treatment. Like we said, this is stage 2 of that wastewater treatment plant upgrade. We've had stage 1, stage 2 is coming. I imagine that in the future there'll be a stage 3, which is likely to include some sort of alternative disposal or use.
So if I may jump in there quickly, Tracy, the decision by council in 2017 was that a wetland would be implemented in the future once certain criteria are met, and a wetland was included in the long-term infrastructure strategy. So it's definitely still in the pipeline, but the scale of that wetland has changed dramatically from what was envisaged originally. Originally, it was a very large system, which was deemed unaffordable for the community. It was in the over the $100 million mark, and so through a process, we changed the proposal to include stage 2 now, what is being implemented now, and then a roughly 15-hectare wetland after this next stage. So it's still in there, but at the moment it's not budgeted for.
Thank you. Now, I'm just going to be really clear here, and this should have been the first question, but can you just be very clear about what the 4 waters are? Because there's been a change, so we might have expected to have 3. What are the 4 waters that we talk about when we refer to them here at GDC?
Okay, 4 waters: water supply, wastewater, stormwater, and what we call land, rivers, and coastal. So we have an extensive land drainage scheme on the Poverty Bay Flats. We maintain the rivers and make sure that they don't impinge on private property. And we do some coastal protection works, although it's very limited. So the 4 waters are, and that's the way that it is land, rivers, and coastal is 1 water, wastewater, stormwater, and water supply.
Thank you, because I guess it's really important for people to understand, and that in this long-term plan early engagement, we are asking for feedback on the first 3. So water supply, wastewater, and stormwater. Now, a question that it might be a separate answer from each of you, and I think we'll start with you, Chris, is that water supply, can we keep up with a bit of population growth? Are we keeping up at the moment? Can we keep up with more people coming to this region as the infrastructure currently is?
It's always a challenge. There's more demands on water, as one of those questions that you had, about water allocation said. If we continue to investigate this new dam, then we'll have more than enough water for Gisborne. The other thing is, if you go the other way, rather than bulk supply like that, people can always reduce the amount of water that they use. And we don't have to waste it. We don't have to wash our cars. I think but there is a level of service that people expect. We can. There's a possible proposal, and it hasn't been confirmed, but we're looking possibly at water metering or demand management, and that has an effect on if you're paying for it, you're not going to waste it, which means there's more for others. So I think the future looks fine for Gisborne and its water supply.
And just quickly to you, Tracy, just currently as our wastewater system stands, can we handle a few more people coming to our region, moving into the city?
We have got some extra capacity at the wastewater treatment plant for growth of the Gisborne population. So again, water, drain-wise, and wastewater are quite closely linked, in that you need to be able to provide the water to get wastewater. And then also drain-wise as well, being able to get that stormwater out and rainwater out of the wastewater system will mean that there'll be plenty of capacity at the wastewater treatment plant. So the wastewater treatment plant has been actually designed with redundancy for growth within Gisborne. It's actually quite a new wastewater treatment plant, being only 10 years old. So really it's, especially at our current growth rate, we've got plenty of capacity there.
That's good to know. Okay, I think we'll wrap it there. Thank you to our subject matter experts who have joined us to talk about our water today. And if you do have a question watching this replay, please, a reminder, send that through to feedback@gdc.govt.nz. Thank you, team. Hei kona.
Thank you.
Thank you.
Bye.